Okay, this is just an alternative way to do the first part of the problems in 8.3. I'm going to show this to you. Just, if you find this is easier, this is a way you are welcome to do this. I'm going to go back and rework all of the same examples that we worked in class for 8.3. So you can look at your 8.3 notes and you can see them worked out there, and then I will do them here, but just stop when we get to the point where it's ready to integrate, because after that everything is the same. So here to start, instead of doing the triangle at the end, in this method you do the triangle at the very beginning. And so if you look at this problem, you're going to go to the piece with the square root. So here you have this, and you have the square root of x squared minus 1, which you won't really be able to tell because it's a 1. But remember that whatever that, so if that were a 4, you'd have a 2 here. If that were a 9, you'd have a 3 here. So keep that in mind. You won't notice it here with the 1. But these are pieces of the triangle, right? So from what we talked about in class that one of these 3 pieces is the square root piece. And then the other 2 pieces, one of them will be x and one of them will be 1. So we know what the 3 pieces are. One is x, one is 1, and one is the square root. We just have to figure out where they go. And so if you look at Pythagorean theorem, you have just the general form of Pythagorean theorem up here. The hypotenuse squared is equal to the sum of the legs squared. But notice if you moved either the a squared over or the b squared over and it became a subtraction problem, that always whichever thing was first, that's always the hypotenuse, right? The hypotenuse is c squared. So if you're subtracting, the first thing is the hypotenuse. And so if you look at this one, this is going to be my hypotenuse. Since I'm subtracting, I know that that first part has to be the hypotenuse. And then this one is one of the legs. So I'm just going to do this the right way, and then after I do it, I'll go back and show you how I knew to put it here. It doesn't really matter. You'd get the same, or not the same, an equivalent answer either way, but one way is significantly easier than the other. And so I'm just going to put it where it goes, and then I'll come back and show you how I knew that, because I think it'll make more sense after we've done it. And so obviously the remaining leg has to be that square root piece. And so what you need, if you look here, you need to figure out to substitute what's dx, what's x, and what's this. You're going to treat this whole square root piece as a whole, right? So you've got the square root piece. Let's move this out of the way. And so you're just using the Pythagorean identities, right? You have hypotenuse, adjacent, opposite, and so you're just asking yourself, okay, which one is this? And so you could either use this with the x, or you could use this with the 1. Obviously, it's going to be easier to use it with the 1. Always use it with the constant, not the variable. Okay, so I'm going to choose it with the 1. And so I would say x squared over 1, that would be opposite over adjacent. So that's tangent. Okay, so I don't really need the 1, but just so you can see. So tangent is that square root piece. And then to get the x, I want to use the x with the constant, right? You're always pairing something with the constant. So x over 1, that would be hypotenuse over adjacent. You always want the variable in the top. So you're pairing it with the constant, but you always want the variable in the top. So I have x over 1 is hypotenuse over adjacent, which is secant. So again, I don't really need the over 1. And then the only other thing I need is this dx. So once I find x, dx, of course, is just the derivative. And so then you can go over here and plug in. So dx you just found from the derivative. X cubed, you would just plug in what x is. And then this whole square root piece is tangent. And again, we just got that from the triangle. So then you have 2 secant tangent over secant cubed tangent. So notice after you cancel, you have 2 cosine squared. And so at this point, that's here we're back to it looking like the one we just did. And so for the rest of the problem, it's going to look the same as what we did, but the nice thing is we've already got our triangle and we already know a lot of this stuff, and so it's not the same pieces we're going to need, but we will be able to use some of this and then get the rest of it from the triangle. Okay, so let me show you how I knew where to put those pieces. Let's say I did it the other way. So I know the x has to go here because, again, whenever you're subtracting, the first piece has to be the hypotenuse. But let's say I put the 1 here. Okay, then when I started this whole same process, right, I would say, okay, I need figure out what the square root piece is. I want to pair it with the constant, make sure the variable's on the top. So I would have adjacent over opposite. Adjacent over opposite would be cotangent. And then to get the x, I have x over 1. Again, you always pair it with the constant. You always put the variable on the top. And so that would be hypotenuse over opposite, which is cosecant. So the question is, which would you rather work with, cotangent and cosecant or tangent and secant? Right? Obviously, tangent and secant is going to be easier than cotangent and cosecant. And so you want to, and this just comes from practice or intuition, or you can memorize it. It's up to you. But you want to always put those legs in such a way that you have one of these 4 and you don't have a cotangent or a cosecant. So that's kind of how you'll know where to put things. So we'll play around with it as we do them so you can kind of practice that thought process. Again, or you can memorize them. Okay, so here's our problem. Again, I'm reworking all the ones from the notes. Again, I'm going to stop when we get to the point where we're ready to integrate. So I would start with my triangle. And now I'm adding. So if you look here, if you're adding, then you would have, hold on, let me see what the problem was. Forgot what the problem was. Oh, okay, sorry, I lost, my brain died for a second. Anyway, so let me rewrite it. Again, you can't really tell because that's a 1. And so if you're adding, then what you have are the 2 legs, right? Because the only time that you're adding is if you have the 2 legs. And so if you're adding, you have the 2 legs. And so again, this just kind of comes from knowing where to put stuff. I didn't take the time to think about it. Let's just stick them up here. Maybe I'll be wrong and we'll learn more from being wrong. So we'll just put them there and then we'll change them later. I on purpose won't think about it and maybe I'll be wrong. Okay, and then the hypotenuse would have to be this other piece. Okay, and then let's see, we have to figure out, we need to know what the square root is, and we need to know what x is so that we can find dx. Okay, so we'll see if we can find those, and then we may have to switch them, so we'll see. So for the square root piece, pair it with the constant and make sure the variable's on top, and then ask yourself what you have. So I have hypotenuse over adjacent. So hypotenuse over adjacent is secant. And then again, because that's over a 1, I can keep getting rid of the 1s. If that was like a 2, you just multiply by it on both sides, right? So if this was over 2, I just multiply by 2. If it's over 3, I multiply by 3, whatever. So you're just multiplying to get rid of that number. And then for the x, I pick the variable, make sure it's on top, pair it with the constant always, see what I have. So this is opposite over adjacent, which is tangent. So I picked them right the first time. Whoops. Let's pretend like I picked them backwards. I was hoping if I didn't think about it, I'd do it wrong. I had a 50-50 shot. Okay, so let's say I put them here. Then notice this would be hypotenuse over opposite, which is cosecant. And then this would be adjacent over opposite, which is cotangent. So again, you don't want the ones that are going to give you cosecant and cotangent because they're just harder to work with. Okay, it's not that they're wrong, it's just they're harder to work with. So don't do it. Don't do it that way. But again, you have a 50-50 shot, so you can just guess, and then if you're wrong, fix them, right? Really, you don't even have to memorize them. Okay, so here I need to figure out what x is. Let me get rid of the over 1. Again, if that was a number, just multiply by it on both sides. To get rid of this, I would divide. I'm going to write it this way. So my dx is just the derivative. And then I go up here to plug in. And so again, I'm treating this square root as a whole. And so that whole square root is equal to secant. So the 3 and the 1/3 cancel. The secant on the top, one of the secants on the top cancels with the secant on the bottom. And that's now back to where I was in my original notes. Okay, so let's try another one. I would recommend, when Jason first showed this to me, it took me a second to kind of wrap my head around it, and it really wasn't until I did one on my own that it kind of clicked. And so if this is still kind of sketchy to you, just pause the video, try this one on your own. And it's really when you kind of play around with it on your own and try it on your own that you're like, oh, now I see it. Okay, so you may not see it till you do that. Okay, so again, start with the triangle. All right, and then remember if you, oh, let me write it here. Why do all of these have a 1? I didn't even realize how all of these had a 1. That's lovely. Okay, anyway, so remember if you're subtracting the first number or variable, that's your hypotenuse. And then the one piece is the 3t, and one piece is the square root. And so you can, again, just try it, and if it doesn't, I'm going to do it the right way this first time because I've already done 2 of them the wrong way, but if you do it the wrong way, you'll know it pretty quick, and then you can just go switch them, so it's no big deal. Okay, so we need the square root piece, and again, these are all 1s. I don't know how that ended up all being 1s, but let's just pretend. Don't actually write this. Let's pretend like it was a 2 just to show you what you would do, just so you can see. Okay, so I have, this is, what is this? Adjacent and hypotenuse. So adjacent over hypotenuse, that's cosine. So if that was a 2, then what I would do is just multiply both sides by 2. So I just have a 2 cosine. Okay, that's what I would do if it was a 2. I don't know why they're all 1s. That's a 1. Okay. And then I need the variable, so I always, again, pair the variable with the constant. Make sure the variable's on the top, paired with the constant. Ask yourself what you have. Opposite over hypotenuse, that's sine. So I'll just divide by the 3. And then go up here to plug in. So treat the whole square root as 1. Oh, I didn't find my dt. First, let's find my dt. Okay, and then plug in my dt. And then you can see now it's back to where we would be in the regular way we did it in my notes. All right, so one more. Again, you may want to, oh, this one's different. You may not want to pause the video and try this one because this one doesn't have the square root, so it's a little different if it doesn't have the square root. But still, you would start with a triangle. And then you would take the piece that maybe should have a square root, I guess is the best way to say that. Take that piece, and it needs to have a square root for the triangle. Okay, so for the triangle, you add a square root. It doesn't have one, but you add it, and we'll fix that in a second. So you add the square root, and then now finally it doesn't have a 1. Hooray, okay. Write it like this. So remember from Pythagorean theorem, if you're adding, the 2 things that you're adding have to be the legs, and so these have to be the legs. I'm going to go ahead and do it the right way, but again, if you do it the wrong way, you'll know pretty quick, and then you just switch them, no big deal. And so then the hypotenuse, it does have the square root, and in the triangle, it's going to have the square root. Okay, and then I need to find, so my square root piece, I put it, the variable on top, pair it with the constant, and so this would be hypotenuse over adjacent, so what is that, secant. And then for my x, again, always pair it with the constant, always put the variable on top. That would be opposite over adjacent. What is opposite over adjacent? Sine. That's weird. Do I have? What did I do? Oh, it's tangent. I thought that was kind of weird that I was going to have a sine and a secant. I just wasn't paying attention. Opposite over adjacent is tangent, not sine. That makes a whole lot more sense. Sine was totally not going to make sense. Anyway, opposite adjacent, that's tangent. Okay, so to get x, we'll multiply both sides by 2, and then I can take the derivative. But then here, notice when you go back up here, let's say I was going back up here to plug in. Okay, I know what x is, so I can plug in for x. But then notice here, it does not have a square root. But all you know is what the square root is. Well, let me solve for the square root. Hold on, didn't do that yet. So multiply both sides by 2. So all I know is what the square root is, but my problem does not have a square root in it. It's totally fine, though. Just square both sides, right? Square both sides. So you got to square the 2 also. So you're squaring the 2 is 4, squaring the secant squared. And so without the square root, it would be that. So that's how you fix it. If it doesn't have a square root, you put the square root, treat it like it has a square root, and then just square both sides. Okay, and then for the dx, I did not leave myself enough room. So I square the 2, that becomes a 4. So 4's cancel, secant squareds cancel, 2 tangent squared, and then I'm back here to what I started. Okay, so that'll work as far as I can tell. That's going to work with any problem. I haven't seen one yet that it doesn't work for. So you are welcome to do it this way, or you're welcome to do it the way we were doing it in class. Totally up to you.